Welcome back. Today we're going to be working on solving equations with variables on both sides with decimals. Our content objective is students will be able to solve equations that have variables on both sides of the equation with decimals. Our language objective is students will be able to state the mathematical properties used when solving equations. And why am I learning this? Well, it's important for real life problems like finding out which cell phone plan's a better deal. So let's just recall from a previous lesson what it looks like when we end up with something like this. First, I want you to understand if we end up with a statement like this, which is false, -8 does not equal -86, then I would say this is no solution, okay, because it's in the form of A equals B, which is not true. -8 does not equal -86. Now, what if instead it looks like this? Then what are we going to claim our answer is? Well, in this case, this is a true statement. It's in the form A equals A. So here I'd actually say my answer is infinitely many solutions. Okay. So here, let's go ahead and try out our first example. What I first want you to understand is this is exactly the same as integers, except now instead of working with integers, we have to work with decimals. But still, we're going to go through the same steps. So the very first thing that I'm going to do is I'm noticing that the best thing is going to be to combine like terms. So I'm going to go ahead and combine a -3 5/10 with a +2 4/10. I'm going to first check to see if I have more negatives or positives. I definitely have more negatives, so I'm going to end up with -1 1/10 x. Here I'm just going to bring down the -7 equals -1.1 x minus 0.9. So because I went ahead and combined like terms, my justification is I combine like terms. And I'm just going to, in the future, abbreviate it SCLT. So hopefully you know that means combine like terms. Now at this stage, I want you to just pause for a second and look at what we have. We have -1.1 x minus 7 equals -1.1 x minus 0.9. Hopefully at this point right now, you can actually tell me it's no solution. There's no way any value for x is going to work. But I still want you to continue on and go ahead and finish and say, okay, well, I want to isolate my variable one side, so I'm just going to go ahead and add 1 1/10 x to both sides. By doing that, notice this is going to cancel out to 0. Oh wait, this side also cancels out to 0, leaving me with just -7 equals -0.9. Here, it's a false statement. So guess what? Like I said, we knew from this stage right here, from that step, it was no solution. But here's further proof. This is in the form A equals B. This is false. And because it's a false statement, I'm going to go ahead and say that this is no solution. Now, one thing I do want to address is this. A lot of students sometimes want to put false as an answer. The question is, what is x? So you won't say false. You'd have to say, well, there's no solution. There's nothing that we can plug in for x to make it work. Now, I did kind of skip something. We were supposed to justify what we did. Here, since we were adding 1.1 x to both sides, I was using the addition property of equality. Now, you might see me abbreviate this in the future as addition POE. So if you ever see that, that's what I mean. Okay? So for number 1, I'm going to say there's no solution. There's no value that I can plug in for x to make this a true statement. Now, I want you to go ahead and pause the video and try number 2 by yourself. Okay, so let's see how well we did. Hopefully, the first thing you decided to do was combine like terms. So notice I'm circling them. Okay, so here, if I combine 7.9 with -8, I definitely see there's more negatives. And since they're different signs, I want to see how many more negatives I have than the other. I'm going to have to find the difference between them, which would leave me with 0.1 x. Just going to bring down that -6. And then on this side, I'm just going to bring everything down. Again, I want you to pause and take a look at what we have right now. I want you to notice that we could technically determine whether or not we have one solution, no solution, or infinitely many. At this stage, I hope you see that the answer is going to be no solution. Why? Because it's changing at the same rate, but starting at different numbers. So here, let me prove my point. If I were to get rid of this, isolate my variable to the left, I'm going to go ahead and add 0.1 next to both sides. But by doing that, that's going to cancel out, leaving me with 0. But this will also cancel out, leaving me with 0, which would just leave me with 7/10 equals -6, which is false. But please remember, they're not asking if it's true or false. They're asking what's the value of x. So here, I want to say just stop at false. I would say the answer is no solution. Now, real quick, let's justify each and every step that we did. Here, notice we combine like terms. Okay, so I'm going to put combine. Actually, I'm just going to shorten it and put CLT. Again, CLT is going to stand for combine like terms. So if you're wondering, that's what it means. Okay, so what did we do to both sides here? Well, I added 0.1x to both sides, so that's using the addition property of equality. Now, real quick, if I subtracted the same number to both sides, then we just call it subtraction property of equality. If I divided the same number to both sides, then I'd be using the division property of equality. So it's almost like using logic. What did I do to both sides? And that's what it is. So here my answer is just no solution. Okay, so back to me. Let me go ahead and go over number 3 with you, and then you can go ahead and try number 4 by yourself. So looking at number 3, I'm noticing the best thing to do might be to distribute first. So I'm going to go ahead and distribute a -2/10 first to a 2x. So that's going to give me a negative times positive is a negative, so that's going to be 0.4x. Now I'm going to distribute this negative 0.2 times 5. That's going to give me a, well, negative times positive is a negative. 2/10 times 5 is just 1. And on the left-hand side, let's just bring it straight down. Now at this point, I could just pause and look. I can determine whether or not I have one solution, no solution, and infinitely many solutions at this point. And here, I can see right away that it's going to be infinitely many solutions. Why, you might ask? Well, because they're exactly the same on both sides. But again, let me prove it to you. I'm going to go ahead and isolate my variable to the left by adding 4/10 x to both sides. That's going to go away. Oh, but wait, this also is going to cancel out, leaving me with just -1 equals -1. Well, this here is a true statement. And we notice if we have a true statement, that means any value we plug in for x is going to work. So this answer is actually infinitely many solutions. Okay, but now let's backtrack and justify every single step that we did. Well, the first thing I did was distribute, so I was utilizing the distributive property. The second step, I added 4/10 x to both sides, so once again I was using the addition property of equality. So there's my justification, and most importantly, there is my answer. Okay. So, like I promised, go ahead and pause the video and try number 4 by yourself. Okay, so for number 4, hopefully the first thing you wanted to do was distribute. 3/10 times 5x is going to leave me with 1 and 5/10 x. And then here, 3/10 times a -3, that's going to be a negative 9/10 equals 0.7x minus 2.9. So here, notice, whenever I can simplify the variables completely on each side, I can technically tell right away whether I'm going to have a one solution, a no solution, or an infinitely many solution. In this case, I know for a fact there's going to be one solution. Why? Because I know for a fact these variables aren't going to eliminate themselves, which is going to leave me with an answer. So here, let's go ahead and isolate my variable to one side. We're going to subtract 7/10 x from this side, which gives you 0. Subtract 7/10 x from this side. That's going to leave me with more positive, so I'm going to go ahead and put 8/10 x. Okay, because I have 8/10 more positives than I do negatives. I'm just going to go ahead and bring down the 0.9 equals, now leaving me with negative 2.9. So now I'm just going to go ahead and isolate variable by getting rid of this minus 9/10. So I'm going to go ahead and add 9/10 to both sides. which now leaves me with 8/10 x equals, here, be very careful. I've noticed a lot of my students, their struggle isn't with the actual arithmetic, it's with the signs. A lot of students are being very careless with their signs. So here, I can see there's more negatives, so I'm going to put negative. And how many more negatives are there than positives? Well, here, if it's 2 and 9/10 and 9/10, there's obviously 2 more. Now, last but not least, I want to get rid of the coefficient. Okay, so we're going to divide both sides by 8/10. So here, to get x, I'm just going to have to divide. So let's go ahead and do, first I'm going to decide right now, a negative divided by positive is a negative. I don't want to get it wrong because I forgot the sign. So now let's do some side work. We're going to do 2 divided by 8/10. I'm going to have to move my decimal over 1 place to the right. Same thing here. Bring it on up. Can 8 go into 2? Nope. Can 8 go into 20? Yes, it goes in twice. With a remainder of 4, go ahead and bring down a 0. 8 goes into 45 times evenly. So my answer is a negative 2.5. Now, is there another method? There is. What you could have also done is at this stage right here, is you could have transformed this fraction slash decimal into just a straight fraction. When we have a fraction, we don't like to have decimals involved, so we want to get rid of that. So notice here, in order to make this a whole number, I'm going to have to make it an 8. And the only way to do that is to move my decimal over 1 place to the right. So in other words, that's equivalent to just multiplying the denominator by 10. So if I multiply the denominator by 10, I would have to multiply the numerator by 10. Negative 2 times 10 is negative 20 over, well, 8/10 times 10, that's just basically moving your decimal over, which leaves me with 8. But I'm not done. If I divide both sides by 4, I would get a reduced answer of negative 5/2, which is equivalent to negative 2.5. Now, I do want you to be comfortable with doing either method, converting this into a fraction, and of course just dividing it out and getting a decimal answer. But to backtrack, let's go ahead and justify each and every step that we did. First thing I did was distribute, so that's using the distributive property. And then here I subtracted 7/10 x from both sides, so this time I actually used the subtraction property of equality. And then here, since I added to both sides, I'm using the addition property of equality. And then last but not least, at this stage right here, notice I was dividing both sides by 8/10. So here I was using the division property of equality. So I used quite a few properties to get to my answer. Okay, so now at this point, I'd like you to go ahead and pause the video and try number 5 by yourself. Okay, so let's see how we did. First things first, I'm going to want to distribute. But before I distribute, I'm going to actually bring down the 6.9x. I'm afraid if I don't take care of it now, I might forget about it. So here, positive 4/10, notice it is positive, times 4x is going to give me a positive 1 and 6/10 x. Now here, a positive 4/10 times a positive 3 is a positive 1 and 2/10. And I'm just going to go ahead and bring down the 9 and 3/10 x plus 2 and 7/10. Okay, so here let's just go ahead and start writing the properties now. I use the distributive property to get to that. Now, what am I going to do? Well, hopefully you see that the best thing is going to maybe be to combine like terms. So here, how many x's are there altogether? 6 and 9/10 and 1 and 6/10 is going to give me a total of 8 and 5/10 x. Bring down the 1 and 2/10 equals 9 and 3/10 x plus 2 and 7/10. Now I notice I do see that there are variables on both sides, so I do want to isolate it over to one side. So let me go ahead and just do the inverse and subtract 9 and 3/10 x from this side, subtract 9 and 3/10 x from this side. I see there's definitely more negatives, and that's going to leave me with negative 8/10 x plus 1 and 2/10 equals 2 and 7/10. Now I just got to keep working. I want to isolate my variable, so I'm going to get rid of this plus 1 and 2/10. So I'm going to go ahead and subtract 1 and 2/10 from both sides. Now that's going to leave me with, let's see, negative 8/10 x equals, there's definitely more positives, 1 and 5/10 more positives than there were negatives. And last but not least, let's divide both sides by our negative 8/10, leaving me with x equals, well, positive divided by negative is definitely going to be negative. So let's do some side work. Let's see, 1 and 5/10 divided by 0 and 8/10. I'm going to go ahead and move my decimal first, one place over. 8 cannot go into 1, but it can go into 15 once. Oops, it's going to be 8. Leaving me with the remainder of 7, bring down to 0. Let's see, 8 can go into 70, let's say about 8 times. With a remainder of, let's see, 6, bring down another 0. 8 goes into 60 about 7 times, which is 56. So here it actually is, if you continue, it actually 8 goes into 40 nicely 5 times. But on your homework, you might have to round to the nearest 10th or to the nearest 100th. Depending on where they ask you to round, only go as far as you need to. For example, if they ask me to round to nearest 10th, I would only have to go as far as the hundredths place to determine whether or not we round up or stay the same. If they ask me to round to the nearest 100th, then I would have to go as far as the thousands place to determine whether or not I round up or down. So please make sure you're reading the instructions very carefully. So here the answer, if I was asked, let's pretend we were asked to round to the nearest 10th. If I was, here is the tenths place. The 7 is definitely going to make the 8 go up 1, so my answer would be negative 1 and 9/10. But wait, is there another way? Yes. Let's remember here we could have converted these into fractions with whole numbers in the numerator and denominator. All I would have to do is move my decimal over at most once. So here, if I only need to move it once, I'm essentially multiplying by 10, which is going to leave me with a negative, let's move this decimal over, 15, over, if you move this decimal over once, 8. So you can say x is negative 1 and 9/10, or you can say x is negative 15/8. They are equivalent in a sense. First, understand that this number here is the exact answer, and this is an estimation. Okay, so for number 6, go ahead and pause the video and try this one by yourself. Okay, so let's see how well we did. So first of all, hopefully you see that we should probably distribute. So here, before I forget, let's go ahead and drop this negative 0.9. Negative 4/10 times a negative 4 is going to give me a positive 1 and 6/10 x. This negative 4/10 times negative 1 is going to be a positive 4/10 equals 1 and 6/10 x plus 0.5. Now here, what should I do next? I think I'm going to combine like terms. So here I'm going to combine negative 9/10 with positive 4/10. Are there more positives or more negatives? I'm going to say more negatives. In fact, there are 5/10 more negatives. Just going to bring down that plus 1 and 6/10 x equals, bringing this down, 1 and 6/10 x plus 5/10. At this point, I can tell right now how many answers there's going to be. Okay, I'm going to say it's no solution, but let me prove it to you. If I were to isolate my variable and subtract 1 and 6/10 from both sides, that would leave me with negative 5/10 equals 5/10. Now, a very common mistake is some people may not pay attention, very close attention to the sign and think, oh, it must be infinitely many solutions because it's true. No, a negative 5/10 is not equal to 5/10. So this is false. And because it's false, the answer is actually no solution. Okay, but let's backtrack a second and justify all of our steps. I apologize, I forgot to go over all the justifications in the previous example, but let's just go ahead and do it for number 6. Here we use the distributive property. Here I went and combined like terms, so again CLT is just short for combined like terms. Here I subtracted from both sides, so that's using the subtraction property of equality. And that was it. That's how I got to my final answer. Okay, so now it's my final one. I'm going to go ahead and show you number 7, and then number 8 you're going to try by yourself. So for number 7, on the left-hand side, I'm noticing I can combine like terms. So I'm going to go ahead and combine 2 and 2/10 with a negative 5 and 92/100. I definitely see there's more negatives. How many more negatives are there than positives? Well, let's see. If you do the math, that's going to be 3 and 72/100. Here, I'm just going to go ahead and bring down the plus 8 and 5/10 x. Now on this side, what should I do? Well, I think I should distribute. Right, I'm going to distribute this negative 8/10 to 4 and 65/100. But before I distribute, I don't want to lose sight of this 4.5x, so I'm going to write it down so I don't forget it. So here, negative 8/10 times a positive 4 and 65/100 is going to be a, let's say, negative 3 and 72/100. Okay, what's a negative 8/10 times a negative 5? Well, that's going to be a positive 4x. So this is what I have now. What should I do next? I think combining like terms might be a good idea, so I'm going to go ahead and combine these terms together. So when I combine these, 4.5x plus 4x is just 8.5x. Let's bring down that minus 3 and 72/100. And here, do the same thing, just bring it down because there's nothing else I can do to simplify it. Now at this stage, I know what the answer is. You can kind of see it already. Notice they're essentially the same on both sides. So I know there's infinitely many solutions. But let me go further and show you in a simpler form why it's infinitely many solutions. If I were to isolate my variable, I'm going to subtract negative 8 and 5/10 from both sides. And notice they're going to cancel out here, but they're also going to cancel out here, leaving me with just negative 3 and 72/100 equals negative 3 and 72/100. This is actually true. Because it's true, I'm going to say my answer is infinitely many solutions. But again, let's backtrack and justify every single step we did. Here, I did two things. I technically combined like terms and use this distributive property. So I'm going to go ahead and put combine like terms, and I use the distributive property. Okay, what did I do here? Well, at this stage, I just combined like terms. Here, I subtracted to both sides, so that was utilizing the subtraction property of equality. And that was it. Okay, so now for the final test, go ahead and try number 8 by yourself. Okay, so let's see how well we did. So for the first thing I'd like to do is I'd like to distribute. Before I distribute, let's not forget this number here because I'm afraid if I get caught up in distributing, I might forget to bring it down. So here, a negative 8/10 with a negative 3, that's going to give me a positive 2 and 4/10 x. Here, a negative 8/10 times a positive 3 and 25/100 is going to leave me with a negative 2 and 6/10 equals. So anything I can do on this side? I'm going to say yes, I can definitely combine these two terms together. I'm going to say there's definitely more negatives. And how many more negatives are there in comparison? Well, I would say there is 2 and 13/100 more negatives. And I'm just going to go ahead and bring down the plus 1 and 9/10 x. Now at this stage, what should I do? I think combining these like terms might be a good idea. 1 and 5/10 plus 2 and 4/10 is going to give me a total of 3 and 9/10 x minus 2 and 6/10 equals, there's nothing else I can do on this side, so I'm just going to bring it down. Again, you're going to notice I like to pause when I'm at this point where the variables are simplified, the constants are simplified, and they're on separate sides. Because at this point, I can determine whether it's going to be one solution, no solution, or infinitely many. And at this point, I can pretty sure confirm that there's going to be one solution. Why? Because I'm noticing there's no way these variables are going to eliminate each other since they're different. So I should end up with an actual answer of x equals something. So here, let's isolate our variable to one side by subtracting 1 and 9/10 from both sides. leaving me with 2x minus 2 6/10 equals negative 2 13/100. Now, to isolate this variable, I'm going to get rid of this minus 2 6/10, so I'm going to go ahead and add 2 6/10 to both sides, leaving me with 2x equals, here there's more positives. How many more positives are there? Well, there's 4,700 more positives. Now, I'm going to go ahead and isolate x by dividing both sides by 2, leaving me with x equals this. Well, I'm going to again show you both ways. Let's go ahead and first divide and see what that gives us. Can 2 go into 0? Nope. Can 2 go into 4? Yes, it can go in twice. Oops, 0. Bring down the 7. Can 2 go into 7? Yes, it can go 3 times with 1. So real quick, if they ask me to round to the nearest 10th, I have enough digits. This 3 is going to tell me the 2 is going to stay the same. Now, if they ask me to round to nearest 100th, I would need an additional number. So let's see what would happen if we had to round to nearest 100th. So let's pretend that was the instructions, the hundredths. We need to round to the hundredths. Okay, so here, 2 can go into 10 5 times. It actually goes in nicely. Okay, but real quick, let's just practice. If they did ask us to round to the nearest hundredth, this 5 would make the 2 go up to 24 hundredths. Okay, so depending. This would be to the hundredths. Now, if they asked us to round to the nearest 10th, then I would say 2/10 because this 3 would not make the 2 go up. So it all just depends what they're asking us to do. Are they asking us to round to the nearest 10th, to the nearest 100th, etc.? Okay, now there was another way. We could have kept them as fractions. Here, to make this a fraction, I would have to move my decimal over 2 places at the most. So since I'm moving it 2 places, I would have to multiply by 100, which means if I multiply this by 100, I would have to multiply the denominator by 100 as well, which would leave me with, moving the decimal over, 47 over 2 times 100 is 200. So here, it's really important to understand, this is an exact answer. This is an estimation, okay? Now this one did work out nicely. It ended up being 0.235, which is 235 thousandths. But now the thing to understand is that might not always happen, so be very careful. So one last step is justify every single step. Here we did 2 things. We distributed, so that's using the distributive property, but we also combined like terms on this side. At this step, I definitely was combining like terms, so I'm going to go ahead and justify that there. Here I subtracted from both sides, so that was using the subtraction property of equality. Here I added to both sides, so that's using the addition property of equality. And last but not least, this final step right here, I divided both sides by 2, so that was using the division property of equality. So that is actually going to conclude the lesson for today. Thank you so much for tuning in, and as always, until next time, bye.